All right, this is Mr. Peterson. We're doing the Honors Algebra 2 Chapter 4 review, and we're picking up with problem 15 as our first one. Okay, on this one, we're trying to solve for the matrix X. You can see there's a capital X right there, which tells us we're looking for a matrix. And we'll start by simply taking this other matrix over to the other side. You have to change the sign when you do that, so let me write down the one that was already over there. And since it was a plus sign on that side, we're going to be subtracting on this side. We'll consolidate those two, but in other words, we'll do the subtraction. Negative 2 take away 4 for the first corner. 19 take away 1. 1 take away negative 2 actually becomes 3 since you've got the double negative involved. And 6 take away 6. Now you have to avoid trying to divide. There's no dividing in this matrix land, as I call it. So instead, you're going to multiply by 1/3 on both sides, which will cancel off the 3 and take us down to x equals, we're going to get our answer here pretty quickly, 1/3 of negative 6 to start. And we get 6, so is 1/3 of 18, 1 there, and 1/3 of 0 is 0, and there's our answer. Okay, the other one on the other side is very similar. We're just going to take this term over, and instead of a negative 2 in front, we'll put a positive 2 on the other side. And it's easiest if you simply do all these corners at once. So I'm going to highlight the ones I'm working on. I'll start with negative 2 plus 2 times 4 would be negative 2 plus 8. And negative 2 plus 8 would be 6. Then the next corner you concentrate on is the top right. Negative 1 plus 2 times 0. That will be negative 1. And then the next corner will be negative 4 plus 2 times 3. So negative 4 plus 6, which is just 2. And the final corner we're going to do will be 12 plus 2 times negative 2. You put all that together and you get 8. Okay, that's it for 15 and 16. Now let's look at 17 and 18. And on these, it's a little more involved. What we have to do, we're trying to prove that these are inverses of each other. And to do so, you're going to multiply them to see if you get I as a result. So we're going to multiply A and B here first, divide the rows, divide the columns, and then we'll simplify these results here to see if we get the identity matrix. If so, the answer will be yes, they are inverses. So to start with, you're going to take the top row and multiply by the left-hand column, and that'll get you this top left corner. Okay, so 2 times 3/8 would be 6/8. By the way, 6/8 is just 3/4. And then the next pair would be negative 1 times negative 1/4, so that's plus 1/4. And you end up with 4/4, which is 1. So far, so good. Okay, the next corner is the top right corner. That's the next one I'm going to do, so I'll be using that row and this column. And if you take 2 times 1/8, you get 1/4. Actually, you get 2/8, but that is 1/4. And then negative 1 times 1/4 would be negative 1/4. So those cancel off and you get 0. Looking good. Okay, so then the next one here would be the bottom left-hand side. So use those bottom numbers on this left-hand side. If you take 2 times 3/8, you get 6/8, which we've seen before is 3/4. 3/4. And then the next one is 3 times negative 1/4, which is negative 3/4. And those cancel off and you get 0. Okay, we got one more to go. We're hoping it turns out to be a 1 so that we end up with the matrix I. And let's see what we get here. Bottom row, right-hand column would be 2/8 when you multiply this one times this one. 2/8 is 1/4. And then 3 times 1/4 is 3/4. And you put those together and you get 4/4, which is 1. So yes, they're inverses, since A times B gives the predicted result of I, the identity matrix. This is the identity matrix right there. Okay, so that one worked out pretty well. We're going to try this next one here. We'll divide the rows and divide the columns. And if this works out, you're going to get 1s on this main diagonal here and 0s in the rest of it. So let's see what you get here. -1 times 3, 2 times -2, and 4 times 2. And sure enough, that gives a 1. Okay, so far so good. Let's move to the next position, which is going to be top row, middle column. So we're going to use these and these. And we'll start out with -1 times -4, which is 4. And then 2 times -3 is -6. And then 4 times 1 is 4. And that turns out to be 2. And that's the wrong number there. It should be, we should have 1s on that main diagonal and 0s everywhere else. So we can stop right there and just say, no, they're not inverses. Since, sorry, it's kind of scrunchy here. A times B is not equal to I. Okay, we'll pick up on example 19